Well, hello guys and welcome back to Mr. G Physics. Here Mr. G, and this time we're going to be solving another question on electrostatic. This one is for the grade 11, however, is applicable for the grade 12 as well. This question says two metal spheres P and Q on a insulated stand carrying charges of positive 5 times 10 to the minus 9 coulomb and positive 2 times 10 to the minus 9 coulomb, respectively. They are placed with a centers 30 mm apart, and X is a point at distance 45 mm from sphere Q as shown in the diagram below. You have all the information here. The only thing I'm going to include here is that this sphere is called P, this one is Q, and then the distance is in millimeters. We are going to convert to meters. This one is 0,03 meters, this one is 0,45 meters. We have to work in meters. The rest of the question is fine. Question 2.1, sketch the net electric field pattern for two spheres P and Q. Now important, X, as you can see it here, is not a charge, but it's rather a point around that electric field of those charges. So we have to draw the pattern for P and Q. So we have here sphere P, and we have here sphere Q. Now, important to have in mind, P is greater in magnitude than Q. So we're going to be drawing for P first. And now the two of them are positive. They're going to repel. Therefore, they will have a pattern in such a way that they repelling each other. So this is how we draw these field lines for P, guys. This one is the field line for P. Because it is positive, this line are be pointing out of the charge. Okay? Now, for Q, the lines are also repelling, but what is the difference with P? They are less line because the charge is smaller in magnitude. So this one have less lines. I don't have to draw so many lines. This one is the one, and this one is also going out. This one is how you draw this pattern for P and Q. If you do that one, guys, you will get 3 marks. 3 marks for drawing that pattern. Now note, P has more lines than Q. Now question 2.2, they say calculate the magnitude of the electrostatic force on charge P due to Q. Now note, Q is pushing P away. So the question is asking to calculate the force that Q exerts on P. This force is force Q on P and is pointing in that direction because it's been pushing away. They are repelling each other. It's been repelled. Okay, so let's calculate here. We have to use Coulomb's law, and then the formula for Coulomb's law, remember, force is equal to K, which is a constant, Q P in this case, Q divided by the distance, PQ squared. That is the formula. Now all the information is given to us. The only thing is K, which is a constant and is equal to 9 times 10 to the 9. This one is a constant that is given to you, times 10 to the 9 Newton Coulomb square per meter square, per Coulomb square. That is the K, and the rest, guys, is to substitute. So let's substitute all the numerical values we have here real fast. And well, if you do this one, guys, you will get that the force is going to be equal to 1 times 10 to the minus 4 Newton. Alright, or you can also, maybe if you didn't use scientific notation, you will get 0,001 Newton, also possible to get. So that is the answer. Mark-wise, one for the formula, one for the substitution of the constant, one for the numerator, one for the denominator, and one for the final answer, any of these. Alright? So that is the 5 marks in this question. Note, lately we are only giving 4 marks for this specific calculation. They're asking you to calculate the magnitude, therefore no direction needed. Okay? Question 2.3, calculate the net electric field strength at point X due to the presence of charge P and Q. So how strong is that electric field at x due to the two charges. So we're going to come to x and we are going to draw the electric field due to both of them. So what happened? Q is pushing x. X is a point, but those points are always taken as positive points. Alright, remember, electric field at a point is force per unit charge, per unit positive charge at that specific point. That is electric field at a point. So this point is going to be positive point. Alright? Therefore, Q1 is going to repel that point, or the electric field at that point is going to be away. Let's say, in other words, this one is E due to charge Q. And then also charge P is going to exert the electric field strength due to charge P is going to be E, and P is also in that direction. This is a vector quantity. This drawing is important because it will help you to know if you have to add or subtract. And this question asks us to calculate E net. That is what we have here. You can see the E, Q and EP are pointing in the same direction. So if we go here and we do question 2.3, we know that E net is equal to EP plus EQ. Alright, and now we're taking direction because we're working with vectors. Both of them are pointing to the right, so I'm going to take right as positive. And then I'm going to calculate each of the electric field at that point. So let's start with EQ. Now remember, it's a non-uniform electric field, so EQ for a non-uniform electric field is K multiplied by charge Q divided by the distance Q square. Alright, so this is how we calculate EQ. When we substitute, we have this one is 9 times 10 to the 9 times charge Q. Now we go to the picture once more. It's 2 times 10 to the minus 9. This one is 2 times 10 to the minus 9 divided by the distance is 0,045, if I'm not mistaken. 0.45. 0,045 square. This one is EQ. Remember, in this formula, you do not substitute the signs. You would get that the answer is 8,888,89 Newton per coulomb. That is the electric field due to charge Q. Now we have to calculate due to charge P. So we come in here. Now we're going to calculate due to P. Now the distance is going to be all the way from P to where that point is, guys. And if you notice, this one is going to be 0,03 plus 0,045. There we go. That is the distance from P. So we're coming here and we calculate the electric field due to P. It is the same. So electric field due to P is equal to K charge P divided by distance P squared. And then when you substitute, you have this one is going to be 1,000 Newton. Here we have the answers now, Newton per coulomb. Okay, be careful with the unit, guys. So now we substitute in there. Remember, right is positive. Both of them are then positive because here the direction is right and here is right. So when you come here, the E net, the net electric field at point X is equal to 8,888,89 plus 1,000. That one will be the magnitude of the net electric field. Now the question also calculate the net electric field, so you need direction as well, right? So let's add this one. Here the magnitude is 16,888,89 Newton per coulomb. okay, and the direction is to the right. This one is the answer for this question here with the direction. Now, how is this going to be given to us the marks? There are 6 marks. One of them for this formula, one of the mark for this substitution, one for this substitution of charge of the electric field at point P or due to P, one for the final answer. There is 1, 2, 3, one for this formula and one for this substitution, 3, 4, 5 and 6. Guys, this is the marks. I hope this question helped. It's a good question to practice the electric field at the point, the Coulomb's law. And thank you for watching. If you like the video, say subscribe for the channel, thumb up. I'll see you next time. Mr. Jim here.